Thank you. Does the mic work now? All right, so for those who don't know me, and I think there are a few new people, my name is Fabrice Mitchell, and I'm a researcher in the great area of human-computer interaction, HCI. And I've been working in HCI research for now the past 15 years or so. And so I'm going to present some projects I've been working on in two sub-areas of HCI that you see here. One is surface computing, and the other one is embodied interaction. So I'll quickly show what these terms mean. But first of all, I thought it would be interesting to define what human-computer interaction is and try to see what it covers. So maybe, I don't know if people here know the term in Japanese, how HCI is called in Japanese. 日本語で何て言いますか? Human-computer interaction. そうです。まあ、もっと日本的な言葉で定義しようとすると、人間と機械の接点における相互関係と対話型操作に関する研究分野です。カタカナを使わない定義ですね。So, a lot of people think that HCI is basically UI, right? HCI is about building user interfaces, researching and designing user interfaces. But actually, HCI is a multi and interdisciplinary field, so it's obviously computer scientists and designers, but there are also many people from social and behavioral sciences, so including cognitive scientists, psychologists, anthropologists who look at the perception and user experience aspects from, let's say, a cognitive and social and even cultural perspectives. Right? So it's not about the technical part, it's also about studying how people interact with machines and computers from a cognitive and social background. And you also have a bunch of artists who use technology in creative and artistic ways. So this is very fascinating too. So associating gestural interaction or displays to create art. Right? So as an example here, I'm going to show, so CHI is the biggest conference, the major conference in HCI. It's held annually. It has thousands of visitors. I'm just going to run, this is the trailer for last year's CHI that was held in Denver, Colorado. And just as an example of the variety of the topics that are covered by HCI, you can see some examples of the sessions. So just an excerpt of some of these sessions here. So obviously you have your AR, your VR, multi-touch and gesture interaction, which is kind of the standard fare. But you can see here you have also health, sound, you have topics that are interesting for us as well, like cars and automation, robot, UI and stuff like that. So it covers a broad range of subjects and topics. So CHI has obviously a technical program with papers and poster sessions, workshops, panels, etc. But it also has courses, student research, design and game competitions. It has a popular demo session, so you can try out all these cool prototypes that you see here. And even it has an art exhibit. So for the past 2 years, CHI has now mentioned art as one of the also output of HCI. And also last year they included telepresence robots for people to attend the conference remotely, especially those affected by the travel ban that was kind of issued right at almost a couple of months before the conference. And so you can see here, it's a big conference, and it's always, you come back from there with lots of new ideas, you talk with people from various backgrounds, it's very inspiring. As you can see here from the model, so you have a bunch of fabrication, VR, touch interaction, music, concert, etc. So I'm more on the technical and system side, and so I'm going to talk about those two areas I mentioned. The first one being, again, surface computing, and especially in that area I worked a lot on bimanual pen and touch input. So I'm going to show a couple of demos, what you can do with that. And the second sub-area is embodied interaction. I mentioned it. And basically the question that you should ask here, so we have different input modalities here, right? It's not your standard Windows icons with mouse and keyboard. You have these new interaction paradigms, and then basically the question is how you design for those, right? How do you take advantage of those input modalities? And so I'm going to start here with a map interface for a tablet, right? Operated by pen and touch. And so basically here the idea is you want to make search queries, and what you can do here is that you can make notes directly on the map as you would do with a paper map, but you can also convert these notes into spatial queries. So I can write what I'm looking for on the map, and then I can draw these circles and lines, and I can create those scopes according to which the query is going to be performed. All right, so let's say I'm looking for a hotel or a shop, and I want to look inside that area and along those lines. I don't want to fill the map with all these push pins. So I can do that very nicely with the pen, right? Imagine if you had to specify that with a keyboard, or draw even a rectangle with the mouse. And it's very easy to do that with a pen, and then you can just simply touch to select. And here this is a routing example, so you can basically connect these pins to say I want to travel from these points, and then it's going to calculate the route. And you can use that route as a scope again, so you can say, so along the way I want to withdraw some money, and I want to look for a bank, where I want to go to a service station, and I can just use that route again to search along the path. All right, so very simple example of what you can do with a pen and touch. I don't have to input anything with the keyboard. So this is another example. It's using a digital tabletop, so a much larger surface. And this is a prototype to do document authoring, document editing. Right? So imagine how you would design something like PowerPoint for a pen and touch system. Okay, so this is shot from the top. It borrows a loose desktop metaphor. You can see using touch gestures, I can collapse and expand slides, and I can see I'm holding the pen while doing that, so I can use both hands or single hand here. And then I can overload these commands, so I can use my left hand as well for touch. But the most interesting thing here is that I can do these hybrid interactions, combining pen and touch together, right? So by pinning an object with the left hand, with a finger, I can drag it off to create a copy. And depending on the number of fingers I put down, so if I put 2 fingers, let's say, I can create a blank slide instead of copying the entire slide. Right? So I have this richness, this vocabulary that I can make use of by having binaural interaction and differentiated pen and touch input. So a couple of more examples here. The default mode for pen, when I just write with the pen, is text input. So I can write using handwriting, is converted into typeset text. And I can insert more text inside the typeset text by just writing in the gap. And then using the left hand, I can enter a command mode, so putting 3 fingers down. I'm overloading again the pen, and I'm changing its mode so I can perform further actions and commands. So here are selections. I can change the font, the color, and then using movements of the left hand, I can change the size of the selected text. And then again in command mode, I can underline, I can also again select the text. You can see a couple of examples. So basically the operations that you could perform with a regular text editor here perform without using a keyboard and using just pen and touch input. Other examples, so this is, I think, quite a nice gesture here, just to perform text alignment. So you can use these chopping gestures just to indicate how you want the text to be aligned. So like left, right, or centered, or even justified by using the 2 hands. Here, this is shape input mode by putting a flat hand. So the left hand defines the general mode of the pen. And now instead of inputting text, it's going to convert the lines into shapes, and I can trace over the outline to increase the size, the width of the stroke. I can perform these slashes to change the style to dashed lines. I can fill the shape with a particular color that I select. I can do that obviously with the contour. And then with the transparent color, I can reduce the width again of the shape outline. Right, so again, I'm not using any keyboard, any menus, anything. It's just everything is handled by pen and touch gestures. If I want to create a new page, I can, sorry, it's a little bit dark. I just basically draw a rectangle in command mode, and then I can choose one from the standard sizes. So from horizontal orientation, I can choose the rectangle I just drew. Undo and redo is supported in what I think is a very intuitive way by making circular motions with the pen, so as if you were rewinding your VCR. So clockwise and counterclockwise for undo and redo. Then there is this content association mode. Basically, if you're writing a letter, you're reusing a lot of content, so this is a bit like a macro. And you can use a gesture in this mode to basically summon content that you often use, right? So you say you write a letter, you have this the header that you want to add, and then you can just basically recall that using a gesture. And I can associate new gestures to new content. So let's say I write this piece of text and I want to associate that with a gesture, so I pin it in that mode, and then now I can reuse that, I can repeat the gesture to recall the text that I've just associated with. And finally, one interesting feature that you probably all use, or most of you use in PowerPoint, is the ability to retrieve clip arts. So you can do that with keywords. So let's say I'm looking for an arrow, and here you can do that simply by shape-based input. So you can just input the shape of an arrow, and this is going to be recognized by the system, and it's basically going to display your different clip art options into that bar that you see here, and then I simply drag and drop the arrows that I want to insert into my canvas. Okay, so that's basically a couple of operations that you can do with pen and touch. So there's some menus, but it's mostly using these hybrid pen and touch gestures. And obviously you need to know those gestures, so that's the disadvantage, but it's a little bit like keyboard shortcuts, right? Those are maybe for experts. It doesn't replace necessarily the menus, so you could start with the menus, and then if you want to be more efficient, you can perform these gestures. I'm going to show another project that was presented last year at ISS, which is basically using the hand contact shape. So the left hand, remember, it's using number of fingers and the flat hand, but here I'm actually using the hand contour itself to trigger different kind of menus, and I can move the fingers to modify some parameters. So here I have like a fan-shaped menu, and then using the thumb, I can use that as a needle to control a parameter here, the saturation of a color wheel. All right, so this is using a very simple computer vision algorithm that basically detects the number of convexity defects created by the fingers, and also shape matching with the angles, etc. And then it basically matches that with pre-recorded templates. And again, here the goal is to support bimanual pen and touch task, right? So imagine I have my menu that I can summon right next to the place I need the menu to be, right? Doesn't appear at the top. It's where I need it to be, it's in place, right? So I can summon that color wheel or that zooming lens right next to the piece I'm drawing, or the canvas where I want it to be. Also, you can support hovering. So again, this is a tabletop, right? And it's using the infrared signal of the tabletop. And I can support some kind of pressure-based interaction here by using the blurriness of the contact shape. So if it's blurry, it means the hand is slightly lifted, and if the contour is hard here, it means that I'm pressing hard on the surface, right? So by detecting the difference in the gradients, I can estimate the pressure. All right, so there were a few examples about pen and touch interaction on surface computing, as I was saying. Now I'm going to show some examples of embodied interaction. So embodied interaction basically is using the whole body to interact with a machine, a display or something. So here I'm going to show a concept to enhance live multimedia presentations where presenters are directly integrated in their presentation environment and content as interactive avatars. Right? So using body gestures, the presenters can control various objects and basically like props. right? And so the target application context here are live stage presentations, and as well as office environments for video conferencing. So here you have like more limited gestures, but the idea is that you're really immersed into your presentation. And this is actually a fantastic setting for that kind of presentation here with that big pillar, and people can't see me behind it. So if actually I were exactly inside the presentation, that people sitting at the back there, they could also see me. Another example here is what we call body lens. So body lens are body controlled magic lenses and personal territories to interact with wall displays. So magic lenses are basically lenses, so focus and context techniques to show, to change the filter of the local area around, inside the lens, right? So let's say if I have a graph here and I want to change the display, so here you have a time-sliced image, and then I can use also the position of the body to change through the time data. Okay, so using hand interactions again, embodied interaction, the whole body, but also the position. Right, so depending on where the user is, you can map that to a certain parameter of the lens, to its size, or even to the filter. So we explored that design space in that work. And we can also consider personal tool belts and clipboards. So let's say you're working in a collaborative setting, you have your own square that follows you, right? So if you move across the display, this personal lens will follow you, and then you have another person which has their personal tool belts and content, and then you can interact, you can work together in this collaborative setting. So this last project here, I just added it here. So it's not necessarily about embodied interaction. It's a little bit different. I think it's interesting because it can heavily benefit from a deep learning approach. So the goal here is to determine surfaces or surface areas that are suitable for projection and interaction with digital information. So imagine we use, so it's a computer vision algorithm that basically is based on random forest and ransack to determine the planar surface and the pixels that have suitable properties for projection. And then we just try and find rectangles within that. So imagine here you have this room with white surfaces around that you also want to use to project content. Okay, you have a bunch of projectors, like people have sometimes mobile projectors with them, and this basic system automatically detects these surfaces that are suitable to project content. And we just built a simple tablet interface here to drag and drop content to these placeholders here, but we imagine also using gestures, right? You can just say, just show that there, just point at the surface, and then it's going to display that content. Maybe you didn't see it here, also there's a kind of adaptation, so depending on the geometry of the frames, the visualization would change. So if it's square, you would have like a pie chart, but if it's a very narrow rectangle with a very, very thin, then it would change into a bar, let's say, right? So we faked that a little bit in this prototype, but I think this is something that we could do nicely with deep learning. So yeah, that's the end of my presentation. I'm a little bit early, but I think we also have a presentation of new members. I'd be happy to answer questions or any comments. I have lots of other projects, other things I could show, but due to the time. Yeah?
Whenever I use one of those systems, especially whenever I try to write and do those kind of functions, I always struggle about the delay between my hand movements and the image or the text appearing out there. So currently in the research area or in the markets, depending on the feedbacks that you got, is it a common concern, or is it just a simple optimization problem of the projects that I use?
You mean the conversion into ASCII typeset text, or you mean the feedback?
For example, in the videos that you showed, I also saw that there is a delay between the human action and the output result of the algorithm.
Yeah.
So there's a process calculation time, and it's always confusing for me to use those kind of things because of that delay. Is it a common concern in the market, or it's just a personal thing?
But so yeah, there needs to be a conversion, and the system needs to know when you've input a letter, when you've input a word, right? And so I would say that is you learn. It's a question of learning, of getting the habit into understanding how the system reacts. Usually you have a separate pad, so it's not directly converted where you input your strokes. I know on tablets, even on Windows, you have a separate pad where you would input your strokes, and then it would appear in your text editor, whatever. If there's a separate input pad, and the output is on another document or other area of the UI. But so here, yeah, there's a certain delay you have to know, but I don't think it takes much time to get used to it. Yeah.
So one issue with things like VR headsets is that it's very difficult to use a mouse and keyboard with the headset. So I was wondering what you would think would become like the default way or the most popular way to say use a computer whilst wearing a VR headset.
Well, it depends what kinds of tasks you're trying to do. If you're trying to replicate, if you want to have exactly the same designs with menus and stuff, so sometimes you have that in like the VR demos, they have these 3D menus, and then you have to basically touch mid-air and have to do this, and it's very error prone. There's probably some more suitable interaction paradigms for VR, and this is still under research. What's the best way, let's say, to model, right? Even to model, you don't have the haptic feedback. And so there are lots of VR conferences at CHI, also you have lots of VR projects. We also submitted a CHI paper just to do basic mode switching. So to change, if you have you want to push an object from one place to another, and then maybe you use the other hand to do something different, right? And so we explored various ways to do that. But yeah, there's still, I think, no standard way like you have for now the established 2D controls for mouse and keyboard. It's still under exploration, also for navigation, because you're confined to a very limited space. Right? In all these games, sometimes you have to travel, but obviously you can't do that. So they have different techniques to do teleportation or jumps, and then there's no standard technique for that yet. Any other questions? Anybody feel that there's a need to have cool interaction in their project? Like you want to have, oh, this looks good. You want to have impressive interactive techniques that you can show to potential customers and say, hey, we need to pep up the interactive part.
Might be a bit relevant to Dennis' question. So, did you work on a project to give a user physical feedback?
I haven't worked on haptics personally, but there are lots of projects that investigate that. There's tons of people working on haptics, and even like in air, so addressing the VR thing. So how to provide touch feedback in air, and there's like Rikimoto Sensei, which you know probably, showed at WIST a couple of years ago how you can use like high pressure, like wind, to try and simulate touch. So yeah, crazy stuff. So if you go to CHI, you see really crazy ideas, and people like are very, very creative working in these areas. All right, thank you very much.